Okay, so today we're going to take a look at trigonometry for the first time. Before we get too far into it, we just got to go over a few definitions and a few things for review. So you've worked with right triangles before in the context of using Pythagorean theorem back in grade 9 or grade 8. And when you're using Pythagorean theorem, you know, the a squared plus b squared equals c squared, you were concerned mainly which side was the hypotenuse. That side was the longest side in the right triangle, the one across a 90-degree angle, and that was the side that was by itself in the Pythagorean theorem. You didn't care what the other two sides were. Now, for trigonometry, we actually are going to care what the other two sides are called. We're going to have special names for them, so we're going to get to that in a sec. But I have two triangles here, and for starters, I'm going to label the hypotenuse in each one of these. So here in this first triangle, again across the 90-degree angle, you got this guy right here, and over here, it's going to be that side there. So that gives us a hypotenuse for each of these triangles. The other two sides of the triangle are going to be called the opposite side and the adjacent side. And to label those, what we need to do is look at, well, it's going to depend on what our indicated angle is going to be. So in each of these triangles, I've chosen an angle to indicate with a symbol here that you might not have seen before. It's called a theta. It's a Greek letter. So sort of looks like a 0 with a little belt. And again, it's pronounced theta. And it's just a symbol that we often use to indicate an angle in a triangle. You see that often in your textbook or further on in these notes, so you'll have to get used to using that one. So we've indicated this angle theta, and we're going to call the side across the triangle from it the opposite side. So opposite to this angle theta is this side right here. Opposite to this angle theta over here is going to be that side there, so that becomes our opposite side. Okay, the remaining side is going to be our adjacent side, so that's going to be this one right here, and this one right over here. And again, for the opposite and adjacent side, this is relative to the indicated angle. If I chose to indicate this angle down here instead, this one here, then the hypotenuse would still be the same one here, but this one would now be the opposite side, and this one down here would be the adjacent side. So again, the opposite and adjacent sides, how you label them, will depend on what your indicated angle is going to be. So you just have to keep that in mind as you're going through this. Okay, so moving on. What I have here is a diagram, and you're going to see there's 1, 2, 3, 4, 5 different triangles in here. And hopefully when you look at these triangles, you'll see that they all have the same interior angles. They all share this angle theta down here. They all have a 90-degree angle, which means the third angle is going to be the same for all of them as well. So since all the interior angles are the same for all of them, they're all similar triangles. And since these triangles are all similar to each other, we know that the corresponding sides in each of these triangles are going to be proportional to each other. So what I'm going to do here is I'm just going to label these sides for a couple of these triangles. So for this first one, this small triangle down here, if I'm using this as my indicated angle, this would be my opposite side, the vertical one right here. The one down here would be my adjacent, and this one along the diagonal would be my hypotenuse. Okay, and I could do this process for every triangle that's here. I'll just choose this other one, this one, the third one in. So this one would be the hypotenuse for that triangle. This would be the opposite, and this whole length down here would be the adjacent side. So because there is a consistent scale factor that exists between all the corresponding sides, we can say the same is true for the sides in the ratios within the triangle as well. So for example, if you look at the opposite side for this big triangle and compare it to the adjacent side for that big triangle, that ratio will be the same for this triangle as it is for this smaller one right here. So there's going to be a specific ratio between that opposite side and the adjacent side. Similarly, there's going to be a ratio for the opposite side and the hypotenuse compared to the opposite and hypotenuse for this one, or the adjacent hypotenuse for this triangle, the adjacent hypotenuse for the big triangle. So there's going to be a consistent ratio between those sides for each of those triangles that all share this angle right here. And that's all trigonometry is. We're going to give special names to these ratios, and we're going to use them to solve for different information within a triangle. So taking a look over here, so there's these three ratios that we're going to name, and you've probably seen these buttons on your calculator before, the ones that look like they say sin, cos, and tan. You may have wondered what they did before, and what they are is just naming these ratios within the right triangle. So we've got a triangle here. We're going to work with this angle, theta. So this sides are opposite, that's our hypotenuse, this one's our adjacent. And this one right here, SIN, it looks like it reads sin, but it's actually short for sine. Okay, we're shortening by one letter there. So we're going to say the sine of the angle theta that we don't know right now is going to be the ratio between the opposite side and the hypotenuse. The second ratio, it's read cos, but that is short for cosine. That's going to be the ratio between the adjacent and hypotenuse within that triangle. And the last one, tan, which is short for tangent, is going to be the ratio between the opposite and the adjacent. Okay, so for any triangle with a specific angle, there'll be a specific ratio that exists between these corresponding sides, and the name we give them is sine, cosine, and tangent. To help you remember these, because you're not going to be given these ratios on a test or a quiz, you have to memorize them. This word down here might help you out, SOHCAHTOA. What it essentially means, SOH, means that S for sine, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So you can use that word to help you remember what these ratios are. And last but not least, you have to make sure your calculators are set to degree mode. This has never been an issue for you before. And most of your calculators probably are in degree mode. I think they go there by default. But what you're looking for is that somewhere in your calculator there'll be a D or a DEG somewhere on the display. If you don't have that, you're likely in the wrong mode, so you have to try and change it. And you have to be careful for a test or a quiz, because if you have the wrong mode in there, every answer that you're gonna do will be wrong. So you just have to watch out for that and just make sure your calculator's in the right mode. Okay, so moving on, let's just try and put this into practice here. So I have a triangle right here, and I just want us to write out the main ratios for both angles A and B, all three ratios, sine, cosine, and tan. I don't know what angle A and B are. In theory, I could solve for them using trigonometry. We're not going to do that yet at this point. I just want to write out the different ratios for these specific angles. So let's just start with angle A here. If I'm starting with angle A, one thing that always helps me out is to label the sides first. So first things first, I have over here the longest side, the one across the 90-degree angle, is the hypotenuse. Go across the triangle from the angle I'm working with. I have this side that has a length of 5. That's my opposite, which makes my last one here my adjacent. Okay, so if I want to write out the ratio for the sine of A, looking up here at my SOHCAHTOA, sine is opposite over hypotenuse. So the side opposite to A has a length of 5, and the hypotenuse has a length of, well, right now we don't know. Can you think about how we could find the length of the hypotenuse right now? There's a chance that thinking back to grade 9 or grade 8, the Pythagorean theorem might jump out at you. So remember, this is the right triangle. We know 2 of the 3 sides. If I call this missing side, let's call it x here, I would have 7 squared plus 5 squared equals x squared. And you can use this to then solve for that missing side in the triangle. So going through a little bit of math here, I'm going to get 7 squared being 49, 5 squared being 25. And when I go through all that, I'm going to wind up with an answer of x being the square root of 74. Now I know you can run that through your calculator and get a decimal, but I want to keep things exact, so just leave your answer as a square root right now. So a reminder, we got all that from remembering that using the Pythagorean theorem, as long as we have 2 of the 3 sides of a right triangle, we can solve for the third side. So that side over here in the equation C, we call x up here is the hypotenuse, and we could solve. So to finish off this ratio, remember that the sine of A is opposite over hypotenuse. So my opposite side is 5. My hypotenuse is now square root of 74. So I can finish off that ratio. Okay, what I'd like you to do now, pause the video and try and write in the rest of these ratios on your own. So the cos of A and tan of A, and then sine B, cos B, and tan B. So again, pause it, try it on your own, and then push play and you're ready to see the answers. Okay, hopefully you've given those a try. Hopefully they went well, but let's just go through them here. So for the cosine of A, cosine is adjacent over hypotenuse. My adjacent has a length 7. My hypotenuse is root 74. Okay, for tan A, tan is opposite over adjacent. Opposite to A is 5. Adjacent is 7. Okay, that gets my 3 ratios for angle A. And for angle B, the one thing I have to be careful of here is if I'm working with angle B, now the side opposite to B is my side that's length 7. So the side that's 7 becomes my opposite. The side that's 5 becomes my adjacent now. And my hypotenuse doesn't change, right? That's still across a 90-degree angle, so that doesn't matter what angle you're working with. But you got to be careful, make sure that your opposite and adjacent have been switched if you're working with angle B instead of angle A. So now, for angle B, sine being opposite over hypotenuse, opposite is 7. Hypotenuse is root 74. For cos B, I get 5 over root 74. And for tan B, I get 7 over 5. One thing you may notice here, if you look at sine A and cos B, they happen to be exactly the same. Same with cos A and sine B. They're exactly the same as each other, which in a way kind of makes sense, right? Because if you're working with a different angle, the side that's adjacent to A is the side that's opposite for B. So that's where you get that phenomenon happening where the sine of one angle is equal to the cosine of the other inside that right triangle. And again, this doesn't actually tell us what the angle is. We could solve it. We're going to do that in some later examples, solving for these angles. Just tells us that in this triangle, this ratio exists between these particular pairs of sides, and that will only exist with a certain angle inside the triangle, which we could find. We're going to work on that coming up in some examples. So right now, we're just writing out the ratios. Okay, so let's actually try and work with our calculators now and try and evaluate some of these. So again, making sure our calculator is in degree mode, I just want to evaluate what the tan of 75 is. So to evaluate this in our calculator, with most calculators you can just type in tan 75. If that doesn't work, you might have what we call a backwards calculator, where you have to put in the 75 degrees first and then push the tan button. But you can just type that in your calculator, see what it gives you, and if your calculator is in the right mode and get it to work properly, it should give you an answer of 3.732. Okay, now what that means, again, we always want to think about what this means, what we're actually solving here. Remember that tan is the ratio between the opposite and the adjacent sides. So what this is telling us is that if you had a triangle, a right triangle that had a 75-degree angle here, that the opposite side would be 3.732 times approximately larger than the adjacent side. And again, we don't know what these numbers are here, but we just know whatever this length is, it would be 3.732 times larger than this length right here, if this angle is 75 degrees. That's what that is. That's what that tan 75 is telling us. So looking at the other example over here, you have sine of 64. Run that through your calculator, and it should give you an answer of 0.899. And what this means, again, sine is the ratio between the opposite and the hypotenuse side, so that ratio would be 0.899 in that triangle. Okay, so now, moving forward a little bit more, going backwards, now I'm going to give you the ratio, and I want you to figure out what the angle is. So what I'm being told here is I have a triangle. The ratio between the opposite and the hypotenuse side is 0.84. I want to find out what my angle is, what angle will create that ratio. So in order to solve here, what we need to do is use a new function in your calculator, another one, that's going to be called the sine inverse. So to isolate for the angle inside this equation, I'm going to take this sine inverse, or the inverse sine, of 0.84. And you can usually find this on your calculator above the sine button. So you look for it there, type in sine inverse of 0.84, and what that should tell you is that an angle of 57.1 degrees will create a ratio of 0.84 between the opposite and the hypotenuse sides. Okay, trying the next one over here. We're being told that the ratio, this is tan, so the ratio is between opposite and adjacent. The ratio is 4 over 3. So using, in this case, the tan inverse, theta will be the tan inverse of 4 over 3. Okay, run that through your calculator, and you should get an angle of about 53.1. Okay, I'm running out of time for this video, so this will be continued in the next part. So we'll see you over there.